So in order to do so, we're going to have to do a little bit of review, okay? So when we're talking about greatest common factor, I want someone with a quiet hand to tell me how we're going to get the GCF of these two numbers. So with Patrick.
So what you do is you list the factors of 15 and 20.
Okay, so let's start with 15. Someone help me out here. Give me one. Yes.
1,
One. Who else? Right.
3,
3. Yes.
5,
5. Yes.
15.
And 50. Are there any others? No? Alright. So let's go ahead and go over to 20. I need some help again. Right to that.
Me.
Yes.
1,
1,
2,
2. Yes.
4,
4. That's good. Yes.
5,
5. And in the back.
10,
10. Are there any others?
20.
20. Any more? Alright, so now that we've listed our factors, how do we determine which one is the GCF? Yes. Yes.
I would circle common factors between them and find the greatest.
Alright, so what are the common factors?
1 and 5.
1 and 5. And which one is the greatest? Yes.
5.
5. Alright, so we've determined that 5 is our greatest common factor. Do we remember the distributive property?
Yes.
Yes. So if I were to write 15 plus 20, what's an equivalent expression? Eric.
5 times 7.
5 times 7. Okay. How do we get 7? Someone want to help him out?
Because 15 plus 20 is 35 and 5 times 7.
Okay, but when we're using the distributive, there's supposed to be something inside, Patrick.
An equation.
An equation. Okay, what do you mean by that?
So instead of putting in a 7, you should put parentheses. Oh, can I change the number? Oh, wait, no, never mind. Wait, can I? May I change the number before the parentheses?
You can.
Okay. Can I please change it to a 15?
To a 15. Why would we want to do that?
Oh, wait. Oh, okay,
All
never
right.
mind. I did mine wrong.
We'll come back to it. Josh?
Well, I was thinking in parentheses, it would be 5 times 3, and then another parenthesis. No, if you erase
Okay.
that thing.
We're talking about distributive though. So when we do distributive, we're going to pull out the GCF. This is what we determined was the GCF, correct?
Mhm.
So this goes on the outside. What's going to go on the inside, Eric?
4 plus 3.
4 plus 3. How do you get 4 plus 3?
Because 4 plus 3 equals 7. And then 7 times 5 is 35.
Okay. If I'm looking at this equation here, we're going to factor out a 5 from this number and this number. Here's our 5. What is 15 divided by 5?
3.
3. That's where this 3 comes from. What is 20 divided by 5?
4.
So that's where the 4 comes from. That's why you're going to set the 4 plus 3 in the parentheses, because you're taking it from these two numbers. Like you guys said, when you add the 4 plus 3, you get 7. And we know 5 times 7 is
35.
35. So 35 equals 35.
Yeah.
Good. Now, if we want to talk about the greatest common factor in the real world, there's different ways you can do it. So Halloween's coming up. Say I want to put together some candy bags for kids that come to my door, right? And I have Snickers and Milky Way. Those are my two favorites, all right? I have 20 Snickers bars and I have 15 Milky Ways, all right? How am I going to determine how many bags that I can create if I want to use all the candy bars and I want the same number of Snickers in each bar, or in each bag, and the same number of Milky Ways in each bag? Yes. You divide. What do you mean by you divide?
Wait, can you tell me the number?
we have 20 Snickers bars, same numbers over here, and 15 Milky Ways.
Divide them into even parts.
Okay, and to do that, we need to take the GCF of those two numbers in. Since we did that, we found that it was 5 already, right? So if I have 20 and 15 of the candy bars, the greatest number of bags we can use is 5, and you'll see why in a second, okay? So, if we have 5 bags, that's the greatest number of bags I can put together. How many Snickers are going to go in there if we have 20 Snickers in each bag? Ethan.
4.
4 Snickers. How'd you get that number?
Because 5 divided by 20 equals 4.
20 divided by 5.
Yes.
4. Good. And how many Milky Ways are going in each bag?
3.
3. Same reasoning?
Yeah.
Alright. That's good. Now, does this look familiar at all to us?
Yes.
Where have we seen this before? Right over here. Exactly. So what I'm saying to you guys is this. If we can take the GCF and we can use the distributive property, using the distributive property will give us our answer for all the problems that we're going to work out during the game, okay? So when you find the GCF, typically that's going to be the greatest number of whatever the question is asking, the greatest number of bags you can create, the greatest number of arrangements you can have, or the greatest number of pages that you can do stuff to, okay? The numbers on the inside are going to tell you how much of each item you put somewhere. So in this problem, we're working with bags. So the GCF tells us we're doing 5 bags. The numbers inside tell us how many of each candy bar are going in each bag. Okay, we got that? No problem. All right, great. So let's move on to the LCM. What is the LCM? What does LCM stand for? Least common multiple. Great. So when we're talking about the LCM, or least common multiple, let's take 8 and 10. All right, how can we get the least common multiple of these two numbers? Yes.
Pick them up, get all the multiples of each one and see the least one that they have in common.
Okay, so what are the multiples of 8? Someone help me out. Do it out loud, all together.
8, 16, 24, 32, 40, 48, 56, 64.
All right, that should be enough, that should be enough. Let's do 10.
10, 20, 30, 40, 50, 60, 70, 80, 90, 100.
I think that's enough, right? Did we find a match?
Yes.
Where's our match at?
40.
Say it.
40.
40. Here's our match right here. So the first number we come to that appears in both sequences is going to be 40. So that's our least common multiple, right? So when we're talking about least common multiple in the real world, most of the time it's pretty easy. It's just as simple as listing out these things and finding the answer. So we just came from lunch and we had grilled cheese, right?
Yeah.
So let's say that here at PCA, every 8 days, you guys have grilled cheese. And let's say that at Wilmington University, where I go to school, every 10 days we have grilled cheese.
Horrible.
So say we're serving grilled cheese tonight at Wilmington University. That means that today, both of us ate grilled cheese.
Yeah.
When's the next time that's going to happen? Josh?
In 40 days.
In 40 days. Because as we already talked about, the LCM, or the number of times that it's going to happen and they fall on the same day, is 40 days. Alright? Now, they can get more complicated. Say we were serving burgers today instead. Okay? We all know with a hamburger, you need a bun and a burger, correct? You're not going to make a hamburger without one or the other. So, the problem comes with burgers come in packs of 10 and buns come in packs of 8. So if the cafeteria wanted to serve the least number of burgers, but they wanted to use all that they had bought, how much would they have to buy if buns are in packs of 8 and burgers are in packs of 10? Let's go, I want to see some, oh, Alan, there we go.
You would have to buy 4 packs of buns. And, you have to buy 5 packs of buns.
Alright, so we're going to buy
4 packs of burgers.
4 packs of burgers. That was great. A lot of people in the previous couple classes were saying 40 because they were just picking that LCM. You're going to use the LCM in a problem like this. You need to know how many you need to get to, but then you need to take that information and do exactly what Ellen did. He said, I need 40 buns, but they come in packs of 8. So you divided 40 by 8 to get your 5. Exactly. Burgers did the same thing. He needs 40 burgers, but they come in packs of 10. So he divides his 40 by 10 to get his 4 packs. Okay? So, is everyone pretty much straight on how we're going to use the GCF and the LCM?
Yes.
Alright. Well, in this game that we're about to play, it's not told to you on the papers that you're going to be looking at whether it's an LCM or a GCF problem. So how do you think we're going to determine whether it's a GCF or an LCM? Go ahead, Joe.
Well, if it wants us, if it's a least common multiple one problem, then it's asking how many can you have.
Let me rephrase my question, I'll get a little bit. If it's going to be a greatest common factor problem, what key word might you find in that problem that's going to tip it off to you that it's a greatest common factor?
Greatest.
Greatest. You're probably going to see greatest in the greatest common factor problems. If it's an LCM, what word should you not see?
Greatest.
Greatest. Alright, if it's an LCM, it doesn't necessarily have to say least, but it might. So if you see greatest, you know it's going to be a GCF. If you don't, chances are it's an LCM, okay? Alright, so the game we're going to play today is called Scoot. Do we know how to play that?
I've heard of it. No.
Okay, well, each of you, there's papers that look like this at your table. First things first, every one of you get a paper.
That's exactly three.
You need another one?
We had exactly.
Do you need one too? Thank you. Alright, so the first call you're going to make is hot dog style. Once you have folded it hot dog style, you need to fold it into thirds. So you're going to fold it half of the way and then fold the other half in. And when you open it up, you should have 6 spots. The 6 spots on your paper are going to represent the 6 stations that you're going to move to throughout this game. Now, in this game, you're going to be asked to be different things like a gardener, a chef, maybe a professional athlete. One thing that you're not going to be asked to do is become a magician, because I've already done that for you. You already have the questions. Just go ahead and move your privacy covers on.
Move them out of the way.
Move them out of the way.
Okay, here we can.
Whoa, yeah, that just happened. So, the way this game works is I'm going to time you guys. I want to see if you guys can beat the timer to solve these problems, okay? When the timer goes off, we're going to do what's called scooting. So when you hear me say scoot, you're going to get up out of your seats. You're going to move to the next station. We're going to move this way, guys. All eyes up here. We're going to move this way. So this table will come here, this table will come here, this table comes here, and so on and so forth. We're going to move in a big circle, okay? So let's just practice that one time. Let's get one scoot in, all right? Try the scoot. Go to the next station. Take your papers with you. Don't forget your papers.
Stay where you are. Stay where you are. Don't be part of the boys. Just because you're the only group of 5. So they were 4.
Now, at each station, you'll see that the first sentence says, you are a blank, whether it's chef, whether it's professional athlete. When you get to that problem, where you're going to do your work, label it as such. So this table, in your first block, you'll put chef, so that I know which work goes with the chef problem, okay? This table, you'll put stamp collector in the first block. And you'll just do that every time you switch, okay? Now, when we scoot, that's not a time to get crazy and start running around and talking real loud, okay? That means we need to get to the next table so that we can beat the timer for the next round, okay? So we need to get to the next table, but we're not gonna run and push and shove, okay? And then we're gonna solve our problems. Now, I think you guys can do these problems in under 7 minutes. That should be very easy for you guys. So I'll put 7 minutes on the clock for the first one, and we'll see if you guys can beat it. Then we'll determine whether we're gonna go lower on the next one, okay? So 7 minutes starts now. And if you get done early, I want you to draw me a visual that proves your answer is correct. Whether it's a picture, just listing out the terms, whatever you need to do, just prove to me that you know how to solve this problem. First thing you need to do is determine whether it's a GCF or an LCF, right? Alright, so then what are the steps you need to take to get there, alright? To make sure you answer all questions on the paper. Don't just find the GCF, you use it to answer the next question.